Let's start with number 3 for the practice problems, section 5.4. This first set of problems highlights what you should do first every time you factor a polynomial. You should always check and see if all terms have a common factor. Just like we did with quadratics, we do that with any polynomial. Look to see if they have a common factor. So see that these have a factor of x in common, and the numbers have a factor of 7 in common. So when you factor a 7x out of this term, we get a 2x left, and here we get a negative 3. So that if we were to distribute the 7x through the parentheses, that's what we would get. Let's look at number 7. And we're going to keep doing this if we can. In any of the factoring problems, we're going to factor out a common factor, a common monomial. Alright, so, and we'll factor it. If we can factor it anymore, we will. So we'll look at both of these terms. They both have a y to the third in common, and they both have a factor of 3. So this will give us y squared minus, this is 3 times 16. So you get y squared minus 16. This here is a quadratic. It's specifically a difference of squares. Okay. If you don't remember difference of squares, or if that doesn't occur to you, that's fine. You can just think of this as a regular old quadratic. And we could say plus 0y minus 16. And say what multiplies to negative 16. Multiplies to negative 16 and adds to 0, and that would be plus 4 and minus 4. Okay, so now this is completely factored. And so we'll move on to number 10. X cubed plus 8. So this section is already titled, telling you exactly what you should be looking for. You should be looking for a sum or a difference of cubes. And this is a sum of cubes because we're adding together. Adding is called a sum. So the thing that you need to recognize is what's being cubed here and what's being cubed here. Well, obviously, x is being cubed, and here 2 is being cubed. Now that you know the two things that are being cubed, this will be a and this will be b. If you look back at the previous video, or if you look back a few pages in your book from here, you'll see, well, let's just go ahead and write it down. We'll write it in our little memory bubble here. Sum of cubes, something cubed plus something else cubed equals that first thing that's cubed plus the second thing that's cubed, that quantity times the first thing that is being cubed, you square it, back up, it's minus the first thing times the second thing plus the second thing squared. Okay, so remember, especially this second one, this is one that throws people off the most often, the second one here, that one needs to be squared. Okay, don't confuse 2 and 8. Let me see if I can clarify what I mean. So a lot of times what people will do x plus, and what's supposed to go here is 2, because 2 is the second thing cubed, but a lot of times people will put 8, because that's the second number. Okay, but just write it down this way so you can be clear. The first thing that's cubed is x, the second thing that's cubed is 2. So it's x plus 2 times x squared plus 2 times x, that's the first thing times the second thing, just written in the normal order, plus something needs to be squared here. What's squared? The second thing that's being cubed. 2 is being cubed, so we square 2. A lot of times people will put 8 squared. So just be careful. Okay, And as I said before, when I talked about sum of cubes, this won't be factorable. At least not in any of the problems that we're doing. Let's try a difference of cubes. We'll make that number 16 a little bit more of a challenge too. 192w cubed minus 3. And the thing that we should do first is the thing that we should always check and see if we could do first, just like we talked about up here. See if all the terms have one factor in common, and they do have a 3 in common. So let's see. You can tell that this has a factor of 3 because you can add the digits together and get a multiple of 3. So you know it's divisible by 3, but what is 192 divided by 3? It's 64. So we get 64w cubed minus 3. No, minus 1. Okay. So now we need to see this as a difference of cubes. We need to see something cubed and something else cubed. So we have 3 times. Well, we could cube 4w. 4 cubed is 64, and w cubed is w cubed. And 1 is 1 cubed. You can multiply 1 by itself however many times you want. You still get 1. Let's bring this up here. Okay, so right inside the parentheses here, we have something cubed minus something else cubed. So we have a cubed minus b cubed. That's going to be a minus b times a squared plus ab plus b squared. That's a difference of cubes. Okay, so now we have 3 times. Now we're going to factor this difference of cubes using this pattern here. So the first thing that's cubed is 4w, and the second thing is 1. So that's this first part. A minus b is 4w minus 1. Next we have 4w squared plus 1 times 4w, so just 4w, plus 1 squared. Then we get 4w minus 1 times, what's 4w squared? Well, 4 squared is 16. W squared is w squared. Plus 4w plus 1 squared, which is 1. And that is the complete factorization using difference of cubes. Okay. Next, we'll move on to number 19. Okay, so you see this is called factoring by grouping. Now the cool thing is, in section 4.4, we were factoring, let me write this down really quick, these kinds of polynomials. And by these kinds I mean something that had a coefficient in front of x squared, something that wasn't a 1. And we took this and we drew this little x and we multiplied a times c, and here we put b, and we whatever. We did all that. And we wound up with a polynomial that was 4 terms long. There was a term here, 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 and here, and we factored these two and these two and looked for common terms among each group. Okay? That's exactly what we are going to do now. That is called factor by grouping. And so for instance, number 19, as I've already said, we're going to do the exact same thing. We're going to group these two and look for common factors among each group. So this group has a y squared in common. Okay, so that's y minus 7. And this group has a 4 in common. That's 4 times y minus 7. And wouldn't you know it, these two wind up being exactly the same. And what that means is this term and this term both have a factor of y minus 7. So we're going to factor out a y minus 7 as a common factor. And when you factor a y minus 7 out of this term, you get y squared. And out of this term, you're left with a 4. Okay? And then we would look and see, can we factor this guy right here? And it's almost a difference of squares, but it's not. It's a sum of squares. And there's no way to factor a sum of squares, at least not, you know, very nicely. So we just leave it that way. So next, we will do number 22. Just quickly another example of factor by grouping. Okay, so we'll group these two and see what happens. So these two have a factor of, it's pretty obvious, 25. And also s squared. So factor 25s squared, out of there you just get s. And a 25s squared, out of this you'll get minus 4. Okay. Now what do these two have in common? Nothing. They don't have a 2 or an s or anything like that in common. So typically we just factor out a 1. It just makes it easy to see. But since this first term is negative, I always like to factor out whatever I'm factoring, make it negative. So I'll factor out a negative 1. And that would turn this, when you factor a negative 1 out of negative s, you're left with positive s. Factor a negative 1 out of positive 4, you're left with negative 4. That's because typically this first term is going to be positive, which means when you factor it, this first term is going to be positive. So, and you want these two to be the same, so we should make this first term positive. And that is accomplished by factoring out a negative if this first term is negative. So we have a common factor of s minus 4. And factor out an s minus 4 from this term, you're left with 25s squared. And from here, you're left with negative 1. Okay. Now, this is factored as much as it can be, because this is a power of 1 right there, so that's not going to factor any further. This one, though, is s squared. Can we factor it? It is a difference of squares. This is 5s squared minus 1 squared. S minus 4. Sorry if my s's don't look very s-y. So a difference of squares factors as 5s plus 1 times 5s minus 1. And now it's factored as much as it can be. Alright, now we'll move on to number 25. A to the 4th plus 7a squared plus 6. Alright, so using the few patterns that we have right now, we would look and see if we could do maybe a difference of squares, a sum of cubes, difference of cubes, factor by grouping. None of these would work. For one thing, sum of cubes, difference of squares, those all have 2 terms. And this does not have 2 terms. Factor by grouping will fit a quadratic that, or not a quadratic, but a polynomial that has 4 terms. This doesn't have 4 terms, it has 3 terms. The only time that we have something that is 3 terms long, and that we can factor, is a quadratic. And that's exactly what this is. Let me hopefully help you see this by moving over here. What if this, instead of a to the 4th, what if it was just x squared, just like a normal quadratic, plus 7x plus 6? Just this thing has a square here, this thing has a 1 here, and then your constant. Well, we'd go like this, and we'd say x, and we would say what multiplies to 6 and adds to 7. That'd be 6 and 1, and it's factored. Well, the truth about this guy over here is that it is exactly like this. It is something squared and something that same thing to the first power. Right, let's now put parentheses here. Parentheses squared plus 7 times parentheses plus 6 parentheses to the first power. Okay, so now we have a parentheses, like a blank spot instead of an x. So if we were to factor this, whatever was being squared, that would go here, and we'd say what multiplies to 6 and adds to 7? That'd be 6 and 1. Okay, can we fill in this blank spot, these parentheses, so that we get something squared is a to the 4th, and then that same thing to the first power is a squared? Well, how about a squared? A squared squared is a to the 4th. A squared to the first is a squared. So it is a quadratic form. It's something squared. In the next term, it's that same thing, just not squared. It's to the first power now. And then you have your constant term. So here we have a squared plus 6 and a squared plus 1. It's in quadratic form. It is exactly like this, only this x basically is replaced by a squared. If you square a squared, you get a to the 4th. If you leave a squared alone, you get a squared. Okay. Let's do another. It's number 28. M to the 6th plus 12m to the 4th plus m squared. As always, we should check and see if we can factor something that's in common among all three terms, and we can factor out an m squared. Get 36m to the 4th plus 12m squared plus 1. So now we have a quadratic. It's 36m squared squared plus 12 times m squared, but now to the first power, plus 1. That is a quadratic. So now we factor this just like we would any other quadratic, as if this were x squared and x to the first. And since this number out here, this coefficient, is not 1, we like to use this method. We do a times c, so that's just 36. This is 12. So what adds to 36, or multiplies to 36 and adds to 12? That would be 6 and 6. And what do we do with that? Remember from section 4.4, we just write it like this: 36m squared squared plus 6m squared plus 6m squared, because those add up to 12, plus 1, m squared times. Now we group these together. Here's a group. Here's the second group. This group has 6m squared in common. And if we factor to 6m squared from here, that's a single factor of m squared, so we have another factor of m squared left. So we have 6m squared plus 1. So 6m squared times 6m squared plus 1. Plus, there's nothing in common between these two, so we'll just make it 6m squared plus 1. And these two have a factor of 6m squared plus 1 in common. So you have 6m squared plus 1 times 6m squared plus 1. And if we wanted to write it a little shorter, 6m squared plus 1 squared, because it's exactly the same thing. Right, number 32. Y to the third minus 5y squared equals 0. So now we are not just factoring, but also solving equations, just 1, 2, maybe 2 more steps after factoring. So we'll look at these two terms. Can we factor out something in common? Yeah, we can factor out y squared, and we get y minus 5 equals 0. So that's factored. That's really simple. You just factor out that monomial, and we're already factored. So we have something times something equals 0. And so one of these things, whether it be y squared or y minus 5, has to be equal to 0. So, we could take the square root of both sides and we get y equals 0. Add 5 on both sides and y equals 5. So there's your two solutions for that one. Let's go on to 34. Yeah, g to the third plus 3g squared minus g minus 3 equals 0. So now we see these four terms, and so we have these four, or these two groups of 2. These two have a g squared in common, so we get g plus 3. And let's factor a negative 1 out of these two, so we get g plus 3, positive g plus 3. And now these have a factor of g plus 3 in common. You get g squared minus 1. So good, now we factored it. So something times something equals 0 means one of these, whether it be g plus 3 or g squared minus 1, have to equal 0. So we just solve for both possibilities. So g could be negative 3, or g squared could be 1, and g could be equal to plus or minus 1 when we take the square root of both sides. So negative 3 or plus or minus 1, those are the solutions to number 34. Okay, so I'm looking at all these that you're solving the equation, and I can tell you that they are either going to be factor out a monomial. It doesn't even look like, oh no, there will be some quadratics, so you'll have to treat some as quadratics, and then they'll have factor by grouping. They don't have sum and difference of cubes. And my guess, I don't know their motivation for not putting those in there, but I would guess that it's what I explained before, that when you do sum and difference of squares, you get a quadratic in the second part, and that quadratic's not going to be factorable, and they wanted it to be nice, so they didn't make it. There would be kind of a little more of an involved problem, so I think that's why they didn't put them in there. So when you're doing those solving, just look at quadratics, grouping, and maybe just factoring out a monomial, a common factor. Okay, so now we have to look at these factoring problems and decide how to factor them. It's easy when they're telling you what to do, but now you have to think, how do I factor it? First thing we should always do is see, can we factor out a common factor? And I'm thinking they all have a 2 in common and an x, so we wind up with 8x squared minus 22x minus 21. And yeah, that's it. Not all these three, they don't have anything in common. So we'll just factor this quadratic here, and we have a number out here that is not a 1, so we'll do 8 times 20, or 8 times negative 21, and we'll get negative something. 8 times 21, we know it needs to be negative, so negative 168. And a negative 22, what multiplies to 168 and adds to 22, or multiplies to negative 168 and adds to negative 22. So this is going to be a positive and a negative number. It needs to add to negative 22. So I don't have any idea. So I'm just going to, well, no idea. So let's divide it by 2. That's definitely not going to work. These are not going to differ by 22. So let's try 168 divided by 4. 4 and 42, still not quite. Let's try 168 divided by 6. 6 and 28. Yeah, so 6 and 28 are going to differ by 22. If I do positive 6 and negative 28, their difference will be negative 22. So now we do 2x times 8x squared plus 6x minus 28x minus 21. So we'll factor out everything we can out of these two, right? We're going to group these together. We've got a 2x, so we're left with 4x plus 3. And these two here, we'll factor out a negative, since this first term is negative, a negative 7. So that will leave us with 4x plus 3, since we factored out a negative. Okay, so now we have 2x times the common factor of 4x plus 3. And when we factor 4x plus 3 out of here, we're left with 2x. And from here, we're left with minus 7. And that is the whole thing. We have factored it using first factoring out a monomial and seeing this is a quadratic and factoring the quadratic. Okay. Let's do number 44. Negative 4b to the fourth minus 500b. So we'll factor out everything that we can that's in common first. So they have, let's pull out a negative, since this first term is negative. Negative 4, you can see that, and a b. So we'll be left with a positive when you factor out a negative here, left with b to the third plus 500 divided by 4 is 125. Okay. And since it's 2 terms long, and this is a cube, I'm thinking probably sum of 2 cubes. And let's see if we can write it that way. Can we write it as b cubed plus something else cubed? Yeah, it's 5 cubed. So this is negative 4b times b cubed, no, not b cubed, b plus 5. B plus 5 times b squared minus 5b plus 25, because that's 5 squared. So that is the factored form of a sum of cubes. Okay. Next we'll do number 50. Z to the fifth minus 3z to the fourth minus 16z plus 48. So, we see there's 4 terms here. If you're catching on, you'll see, or you'll be noticing that if we have 4 terms, we're probably going to do factor by grouping. Group the 2 groups together and see what they have in common in each group. So this group has a z to the fourth in common, so we're left with z minus 3. And this first term is negative, so we're going to factor out a negative. A negative 4. So or negative 16 actually. 16 goes into both of these. Left with a positive z, because we're factoring out a negative, so that leaves us positive, and z minus 3 when you factor out a negative 16 here. And as we should, we wind up with z minus 3 as a common factor. We get z to the fourth minus 16. Here's a slightly tricky thing. When we look at this one and we think, can we factor it? We can. This is z squared squared. And this is 4 squared. So it's a difference of squares. So, difference of squares factors as the first thing plus the first thing that's being squared plus the second thing that's being squared, and then the first thing that's being squared minus the second thing that's being squared. Okay. And this now is also a difference of squares. Z squared minus 2 squared. So we have z minus 3 times z squared plus 4 times z plus 2 times z minus 2. Okay, so not a difficult problem, but one that keeps factoring. You just got to remember to check each step of the way whether or not you can factor it. And we were able to factor that several times. All right, well, that'll do it. That'll be everything for section 5.4. Thanks for watching.